Now, the first strategy here with the Pythagorean identities, that's the sine squared plus cos squared equals 1. The tan squared plus 1 equals secant squared, and the cotangent squared plus 1 equals cosecant squared. Those ones we just got introduced to on Friday, and we just started them in this section. We've already used this second strategy quite a bit, changing things to sine and cos. When you get stuck, if you change things to sine and cos, you can often solve it that way. This isn't always the shortest way. So we looked at some of our examples where we could change it to sine and cos, but changing everything to tan or changing everything to cotangent was sometimes quicker. And that's sort of what I want you, if we sort of skip the third one right now, always be aware of your goal. Be aware of what's on both sides of your proof. If you see right away, hey, I can change everything to tan, that's going to help you, okay? Sometimes you're going to see in a proof that one side has tan squared, the other side has secant squared, and so you're going to have to say, hey, I should use one of my Pythagorean identities because tan squared and secant squared are related. That might be a shorter way than changing things to sine and cos. So being aware of what you want to prove often gives you hints for what strategy you should use. Now the third one is the main strategy. The reason why we practice fractions so much in this unit is you're going to get fractions inside of fractions and fractions plus fractions. And so if you can combine your fractions, getting a common denominator, if you have a fraction divide by a fraction, multiply by the reciprocal, and get a single fraction on both sides of your equation, 90% of proofs can be done that way just using your fraction skills. You get a single fraction on either side. Now, there is that short 10%, and I'm going to write the word stuck right here and highlight it in yellow. There's going to be a short 10% of proofs where you are going to do all this stuff, maybe change everything to sine and cos, get a single fraction on both sides, and you will be stuck. They won't be the same. When you get stuck, there's two main strategies that you can use. They're sort of listed in these last ones here. One of them is factoring. So if you highlight in that in the same color as when you get stuck, if you are stuck, see if you can factor, because that can often be the thing that helps you get past being stuck. And the other one, which I've mentioned already, this is a word that I've made up, build the other side. If you wanted, I think the example that we had a 1 plus secant theta on the bottom. And so we just multiplied the bottom by 1 plus secant theta and the top by 1 plus secant theta. This build the other side is really related to this. It's a beautiful arrowhead. Nice. Multiplying by 1. Because if you want to build something, if you want a cos theta in the bottom of your fraction, well, you can multiply the top and bottom by cos theta and build it. So we're going to see this coming up over and over again. The reason this word conjugate, if you don't remember that word from rationalizing the denominators where you first saw that word, what a conjugate is just a binomial. If I have a plus b, the conjugate would be the same binomial with a minus sign. So that's what the word conjugate means. And it's very much related to a difference of squares. Because if I multiply an a plus b times an a minus b, I get a difference of squares, which would look like a squared minus b squared. So really, this build the other side and this factoring difference of squares are connected to each other. Because you either can solve it by factoring, and then things cancel out, or you can solve it by building it and see how things go. Last little one here is connected to the first one. If you see a 1 somewhere, that comes up in each of our 3 trig proofs, trig identities here with sine squared plus cos squared equals 1, tan squared plus 1 equals secant squared, and cotangent squared plus 1 equals cosecant squared. So if you see a 1, that's giving you a hint. Maybe I can use one of those Pythagorean identities. So these are the strategies that we're going to have. Now we're going to look at some more proofs, and you'll be able to go further than 20 on our sheet there.